right, Yejin Choi, professor at Stanford, MacArthur Genius Award winner, just gave a keynote here at NeurIPS. Thank you for chatting with me today. Excited to dive into all things AI. Do you want to maybe say a little bit about the lab you run at Stanford, the area of research you're doing that you're focused on, and what your keynote was about?
Sure. So I work on a number of different things. These days, NeurIPS excited about reasoning, reinforcement learning,
Awesome.
and how things don't work in the way that we expected them to be, and what's going on.
Oh, wow. Yeah.
So today at the keynote, there were multiple things that I was talking about. One thing is that nothing is easy in life. And I mean it, even with the reinforcement learning, you can arrive at the conclusion that it doesn't work very well unless you do all the things really effortfully and really right. So a lot of my talk was about that. And in fact, some people want to say that RL is more superior than SFT, sequential fine-tuning. But even that, with a lot of effort into sequential fine-tuning, for example, open thought, you can actually win over reinforcement learning-based approaches as well. So there are a lot of these engineering details, design choices that are somewhat underappreciated that actually matters so much in order to see the true power of this method. So there was one angle of my keynote today, and then other angles had to do with how the current method, no matter what you do, it all boils down to data. Because, how sausages, the, LLM sausages are made is starting with the pre-training on the entirety of internet data, the more the better. Unfortunately, AGI doesn't just arrive based on that. So then people start writing a lot of exam problems. The more the better. So this is sequential fine-tuning, basically supervised training on lots of exam problems. And then when that exhausts, people now start doing reinforcement learning. And this sounds more exciting because, maybe the model is exploring instead of imitating. And, this sounds more magical. But under the hood, this all boils down to synthesizing even more data because that much data is still not good enough. And we somehow need to now ask AI to generate more data. And when AI generate data by chance really good, if what AI generated happens to be good based on the reward model, in the eyes of a reward model, then the model, is sort of like indirectly trained on its own successful explorations. So in that sense, it's another form of synthetic data. And that's
it all comes back to data. That's kind of one of your key points here.
Yeah. It's all about data. And this is both good to know for making stuff work, for more immediate benefit, but also in the longer term, disappointing because humans are not as data dependent compared to how data hungry the current
the intelligence we have in our heads.
Yeah, and then especially
we're very sample efficient. So my parents teach me something, and they don't have to pay $1 billion to generate a massive data set for me to pre-train on.
Yeah, but fundamentally, what I'm really worried is that when we think about internet data versus synthetic data, or curated data, hard math problems that human experts sat down and wrote. These are all in the neighborhood of our internet data, which is the artifact of human knowledge. Now, human knowledge is not equivalent to the universe of the actual knowledge out there. There are truth. There are truth about how to cure cancer, for example. There's unknown truth about a lot of things that's not there on the internet, nor, any of these current way of doing curation of data or, even hiring the best scientists and ask them to write the curated data, it's not going to really teach the model how to come up with personalized drugs that could either prevent or cure cancer. So there's something about the fundamental piece that's really missing. So I was trying to raise that question, how do we really get all the way up there?
I guess if I was to summarize what I'm hearing about the points in your keynote, one, on the second part anyway, one is that it all often comes back to data, or always comes back to data. And the way that we're doing data right now is often with this assumption that if we generate enough data from human expertise, we'll get to a powerful model that will help solve big human problems.
Yeah.
But yet, what your observation is that nearly all the most interesting things we want AI intelligence that we would engineer to do would be solve the problems we haven't yet.
Yeah.
And so having scientists kind of teach it what they know, or engineers or lawyers or doctors, doesn't get us there. And so then maybe that brings you back to this point you have about reasoning, is if maybe the special thing about humanity is the distribution of information that represents how we reason. And if we can capture that and have the models learn the reasoning process, then we've set them up to take even what we've already taught them to memorize or learn from human knowledge and fill in the gaps that we haven't taught them, and then continue past that to cure cancer for us.
Yeah.
Does that sound right?
Something like that. But right now, I feel like what we do boils down to interpolation. Maybe a little bit of inductive closure and deductive closure of the internet data or human knowledge. But how do we really, really transcend that boundary of knowledge and then explore this unknown, the great unknown?
Yeah, that's fascinating.
That's the dark matter of knowledge we don't know how to get to.
Amazing.
Yeah.
Have you heard people talking about sort of a taxonomy of the types of reasoning? I would think of logicians or philosophers who spent time thinking what types of, inductive reasoning, deductive reasoning, when we make inferences, when we generalize or project more general knowledge down to specific hypotheses.
Excellent question. Yeah. So like when people talk about types of reasoning, people tend to just focus on induction and deduction, which I did highlight. But what's really, really exciting in my mind is abduction.
Abduction.
Yeah,
Okay,
abduction it's less known. It's due to Charles Peirce, who had this observation that most reasoning, quote unquote, reasoning like induction and deduction is regurgitation of the same information that you already had. You already had information, and then you draw the conclusion. That's just, in some sense, like a paraphrase of what was already in your knowledge. Whereas abduction is this mental act of coming up with best possible explanation of your partial observation. And so you're coming up with a hypothesis.
Right.
And so,
Something
in
new.
fact, when you look at detectives like Sherlock Holmes stories, the author Conan Doyle incorrectly thinks that the detective Sherlock Holmes is doing deductive reasoning. But no. It's not deductive reasoning, because you have to jump to the conclusion with a bit of a leap of faith, which is abductive reasoning, because you have to come up with a hypothesis. And so this is very much what scientists are very good at, or at least some scientists are very good at.
Yeah.
And the hardness of all of this for human scientists, by the way, is the fact that we have to also falsify. Because this was part of my keynote today as well. But when you look at scientific literature, two things that cannot be true simultaneously are supposed to be true, because you kind of have to falsify whatever information scientists share, and it's up for interpretation and correct contextualization that really matters. So falsification really matters to the true innovation, advancements of scientific
falsification
knowledge.
being the ability to test whether a hypothesis is true or false. And so it's tempting for some maybe scientists who, especially if they want to just get a lot of citations, to put forward a hypothesis that has compelling argumentation, but doesn't present an obvious way to test whether the thing's true or false, even if it's expensive. Got it. Yeah, fascinating. And the first point you made, that you brought up at the very beginning here of your keynote, was that there's no free lunch, I think is how I might summarize it.
Good way.
Like RL versus SFT. Maybe a question I've been asking others is there one thing that bothers you that's sort of a myth about AI that you would want to debunk or refute, that kind of drives you crazy? Sounds like for you, this oversimplification of researchers to say, well, this technique versus that technique, the kind of building of camps of, reinforcement learning is the holy grail now, versus, in your opinion, what you've often seen, it sounds like, is the devil's in the details. No, it's like it's like the parameter choices and the experimentation setup and like the small ingenuity that you use to get a result, and not the kind of the core technique.
Yeah, so let me explain a little bit about what contradictory findings were there in the scientific literature about reinforcement learning. So the one of the honorable mention, best paper honorable mention at NeurIPS was about the fundamental limitations of RLVR. So what they found is that I really like this paper from Tsinghua University and other institutes in China. Sorry that I cannot remember all of the co-authors' institutions. So they looked at PESET-K performance before and after RLVR, RL with verifiable rewards. And what they found is striking because PESET-1, so that's top performing sample from the model, does become better after RLVR as expected, but PESET-K performance, so after drawing K samples, check whether any of them happens to be correct and not knowing which one is better answer. PESET-K performance decreases after RLVR, which implies that base model already knew the top roughly good answers within their top K samples. And then during RLVR, you're just fine-tuning just a little bit so that you know how to sort the relative order. So the capacity was already in the base model. And then another really fun paper from UW about spurious rewards, they report that if you do RL on top of Quan, strange things happen.
I think I've heard of this one.
Yeah, don't worry about reward model. Just give any rewards, random rewards, or even deliberately incorrect rewards. No matter what you do, performance goes up. What on the earth, right?
That's crazy, yeah.
What's even weirder is that if you do that for other models like Llama or Olmo, not as much. So there's something strange going on regarding the chemistry between the base model, whatever that base model saw, most likely SFT style mid-training, that's the last phase of a pre-training. What happens, I think, people speculate is that kind of data really changes the behavior of the RL result. So, but anyway, those papers basically pour cold water over the RL vibe. Whereas, so that's, a version that I would characterize as, if you do it RL in the very, very effortless way, you can arrive at that conclusion. But if you put even more efforts in order to overcome that problem by controlling entropy really carefully, there are a lot of recent papers that tries to do that better. So if you try to do it in a more effortful way, you could, to some degree, overcome this. It doesn't mean that we entirely, overcome this problem. It's just still an open research question, but still there are ways to overcome. So I'm still optimistic and more positive that we can make things work better, but it's also really good to know where the limits are.
And that we have to work hard. So there's like an ethos here of
nothing's easy.
Like get your nose to the grindstone again. Okay, great. That sounds awesome. Let's talk about the state of open research, especially in the United States, North America, but also we can talk about it globally. Have you noticed some things shift in your career, right, in the last 5 years, 1 year, 6 months, in terms of the amount of open research happening? And do you have any worries about that? Do you think everything's copacetic?
Yeah, great question. I think there are, in some sense, less and more simultaneously. So the frontier labs, they prefer to close more and more. We did notice that. Meta contributed so much through Llama in the past, but it seems they want to close more, for example. So in that sense, it's a bit concerning. But on the other hand, just the sheer scope, the variety of open source models increased a fair amount, especially now NVIDIA is also jumping on it, but also
with like Nemotron.
Nemotron, and they're very dedicated for supporting open source community. And then in my keynote, I also showed this very interesting blog post from, I think, AI World about the trend over the last 1 year about the number of repositories contributed by different company. And Alibaba really shows up to the top toward the end together with NVIDIA. So that shows how Chinese companies are contributing to the open source community so much more. And I think that really helps China in terms of talent acquisition.
For sure.
Because a lot of, students who did a PhD in US used to prefer, Chinese students in US, they used to prefer to stay in US.
For sure.
But now I see more and more cases where they turn down one of the top companies' offers in US to return to China. So
why do you think they're doing that? Is it that there's a more open posture in China to do open research right now than we see here, or better funding, more access to resources?
I think open science is very attractive for talent acquisition. Is what
and it's more open
speculate.
in China right now.
Yeah. It's very more. I mean, relative to how things are elsewhere. Yeah, it's very.
And not to mention that immigration is much harder for Chinese nationals in the United States right now. It's harder to keep your visas.
Oh yeah, like one funny
instead of
joke,
welcoming, we're like sort of closing the doors.
Yeah, I heard this joke that's funny but not funny, which is that Chinese people contribute so well to AI, such that there are practically two groups of Chinese people competing with each other: Chinese group in China, Chinese group in US. This will no longer be true soon after because they're returning to China.
Yeah, it's pretty fascinating. What's the highest leverage thing you or I can do to change the tide of the amount of openness we're seeing here in the United States?
We need to understand the importance of democratizing generative AI, is my take. What I mean by that is that AI should really be of humans, by humans, and for humans. So what I mean by AI of humans is that AI should reflect human values and originate from, humans, society at large. And that's
versus
ownership.
Being kind of quite a different type of intelligence with a different value system than ours.
So that's ownership. In terms of creation, AI by humans, a lot of different countries and different social sectors should be able to create that AI, not just a few companies in two, three countries.
So by all of humanity versus by a human.
It's too powerful to just leave it to a few.
Yeah, how many would you ideally prefer have their finger on the button?
Everyone, literally everyone.
Truly we're talking
Why
democracy
not?
again.
Yeah. And then finally, AI should be for humans in terms of a beneficiary, in that it should really benefit humans and all humans, not just some humans in power.
Yeah.
And more importantly, AI, if we don't really worry about this, I'm deeply worried about this beneficiary part. So if we don't really work on this hard, we could be facing a future in which instead of AI serving humans, AI might be serving AI. Or even worse, humans might be serving AI. I mean, to some degree, maybe this is already happening and we got to do something about it. And just doing better on math benchmark is not going to solve this problem, is my take.
I wholeheartedly agree with you. Do you think that open source and open weight and open discourse researchers, people committed to the open side of research right now, could be doing a better job teaming up to put forward fundraising efforts and to put forward collaborative environments where we're sharing our roadmaps and building common artifacts, sharing GPUs in a way that our projects are building off of each other better? It's a little bit of a loaded question because I do believe that. And I think that in the history of academia, we've been very cooperative. As somebody very early in my PhD used that word when I wanted to collaborate with someone at CMU. And the CMU students' advisor said, "Ooh, we are working on pretty similar things. We should be cooperative." And I was like, what does that mean? Can't we just be collaborative? I think academia has historically been a little bit close to the chest and very independent, fiercely independent, even with our projects. Do you think that there's perhaps an opportunity in a new era where, in slightly more dire circumstances, with all of the big labs having closed their doors, we need to collaborate across research labs and universities and open and non-university nonprofits in like a fundamentally more efficient, more committed way?
Yeah, 100%. In fact, we are so aligned in this thought. I'm almost surprised to hear this because another angle of my keynote earlier today was David and Goliath.
Yes.
And what open source community can do better in order to join forces together. And for that, I was highlighting we need something unconventional. It's got to be unconventional.
Yes,
We cannot
agreed.
have no compute, no nothing, somehow wish for the log. No, log is not going to come.
Yeah, we can't keep doing what we've been doing.
Unconventional data, algorithms, and then collaboration. What I meant by collaboration is basically cooperative, something unconventional that goes beyond the boundaries of institutions. And one example that I wanted to highlight was open thought, because it's really different genre of paper writing.
For sure.
Where, like different universities, I'm a very insignificant but very proud co-author of that team, because it's just like so many different universities and people and even like companies contribute however way they can contribute.
Yeah.
I really think that we have to do things in a way that's really unconventional.
Yes.
And in order to do that, one thing we have to fight against is ego.
Yes.
When everybody wants to be the first author and last author, we can forget about it.
For sure.
So,
and that is pretty deeply seated in the academic tradition.
Oh, yeah.
And the sort of, we self-selected in academia for fierce independence and H-index being our primary metric.
Yeah.
So I think what you and Ludwig and others at Stanford have been doing, and even Percy with Marin, is a new type of research. I think Dave Patterson at Berkeley with the labs that he started, like Rise and AMP that I was in, but then Jan Stojka and Matej, we've got a collaborative approach as well that is highly complementary, and Laude embodies that. Terminal Bench was actually, because it was a team up with Ludwig in the same group that was the data comp people, the authorship is very large. I'm an author on the paper. I made one task instance, but I also advised the project, and we brought resources to the project. And I think it's the first time I've seen a research project, and I know Ludwig has done this before. It's the first one I participated in, where we basically crowdsourced the authorship and find a model of incentivizing, which was you get to be a co-author if you submit 3 tasks. And PhDs were willing to show up to these 24 people like inside Zoom meetings, and it was people from CMU and MIT and Berkeley and Stanford and UW. It was super inspiring and way more fun for every student on the project. And now we've got these meetings that we have in San Francisco, and like flying people here to NeurIPS. The Open Thoughts agent team is just hanging out here all over and collaborating with other people in the stack like Marin and DSPi. So I think that we are at the edge, actually kind of poised to roll out and maybe get a lot more attention for some bigger, very unconventional team up across
thank you
all
so much
open
for
researchers.
Driving the mission for doing something unconventional. I really appreciate it.
This was a wonderful chat. Thank you for
so much.
taking the time.
Yeah.